Previously, when we derived this martingale process, the process are all single factor processes, or stated another way, those processes all have just one random factor there. But we can easily expand them to multi-factor. The final form of a multi-factor martingale process will be like this. Essentially, you have a whole bunch of Z, each one is Zi, so you have a whole bunch of dZi here. And you have a whole bunch of things that multiply to this dZi. Okay, now how do we get that? Essentially, we follow the same way. So if you look at a multi-factor process, that process will have factor Zi, and so your variance here is really the sum of all those sigma fi times dzi. And for the for it to be no arbitrage, we know that there must be risk-free rate plus a factor here that's using the numerator asset sigma g. This volatility of the numerator asset, which is sigma g, as lambda or as the risk price. Now, it has a whole bunch of sigma g's. There's a sigma gi, I for each of the random process zi here. So you have that price multiplied by this sigma fi. So this part is the volatility of this process process f. The volatility for that random factor zi is sigma fi. Okay. Now, once you have defined it this way, you can just go through the same approach we have done before. Now it's just with multi-factor. So you can take the log of f and the log of g, and then look at what process does log f and log g follow. And this part relies on Ito's lemma. So you use Ito's lemma to derive this. And once you have done that, you can then say, okay, apply Ito's lemma again to find out what is d f divided by g, right? So the function applied on this one is e to the power of log f divided by g. So apply Ito's lemma again with some manipulation. You will get this multi-factor version of the martingale process.